Hello and welcome to the Big Bang Kilonova Hypothesis podcast or vlog. This is the second episode in my making of the next film in my series, which I'm going to call The Anatomy of a Kilonova. You can watch my original film, which covers the entire thesis of the Big Bang Kilonova hypothesis in my last film here on my website. I'll post a link down in the description. In this particular episode, I particularly want to look at some of the new artwork I've developed showing neutron stars and kilonova and talk through some of the inspiration of that artwork, and also give you a little bit of more background about myself, about where I come from in terms of I've been doing computer graphics since the age of 6 and since 1982, and I'm quite well versed in it. So if you ever want to know how the back end of Blender works and the algorithms computational mathematics within it, I've got a pretty good idea of what some of the things that go on in there. But the first thing I want to talk about is this little thing that really has been getting to me. It's not a little thing. It's it covers the myths, legends, alchemy. I want to talk a bit about alchemy, as in the precursor to chemistry, because the holy grail, as if it were, of alchemy was something called the Philosopher's Stone, and the Philosopher's Stone is supposed to be the alchemical substance that transmutates base matter or base metals into gold. So a lot of people in the medieval times went to the mystical. Well, it was more a mystical outlook or Gnostic outlook, as opposed to, say, the scientific method of coming to learn, or the way of learning of knowledge, was essentially down to mysticism and Gnosticism, rather than, say, the scientific method of hypothesis, experiment, observation, and conclusion, and the continual cycle of the scientific method, really. But I want to talk about the Philosopher's Stone, because we are really talking about the Philosopher's Stone when we're talking about kilonovas, because that's exactly what a kilonova is. It's where gold comes from. All the gold in the universe, or most of it, gets made in the collision of two neutron stars. And so, in order to show this little scientific fact, rather than it's a science. I want to show the science of how a kilonova is the Philosopher's Stone, because that is one of the central tenets in my film, and in sort of really fact checking in really doing the homework of my own research. I want to go through this article from Harvard. Well, as you can see, Harvard University, one of the top universities in the world, particularly when it comes to their physics and computer science and astronomy. This is from the Department of Astronomy. So let's go through it, and I'll explain some of the things as we go. So it's called Cosmic Alchemy. Colliding neutron stars show us how the universe creates gold. For thousands of years, humans have searched for a way to turn matter into gold via the Philosopher's Stone. And actually, let's look at the wiki page for the Philosopher's Stone. So I'll just bring up a new tab. I'll just type in full law. There we go. And basically, Wikipedia, as we describes it, the Philosopher's Stone, or more commonly Philosopher's Stone, is a mythical alchemical substance capable of turning base metals, such as mercury, into gold or silver. There's the whole side of the elixir of life thing, but the reality of, if you ever actually got exposed to a kilonova, I would put the estimate of your lifespan to be in the nanoseconds. You're just going to get vaporized instantly. They are the most powerful explosions, or some of the most powerful explosions in the universe. And they give birth to a black hole. So, colliding neutron stars, kilonovas, shows how the universe creates gold. And that is the Philosopher's Stone from alchemy. So for thousands of years, humans have searched for a way to turn matter into gold. Ancient alchemists considered this precious metal to be the highest form of matter. There is a description in gold being eternal. It's the eternal metal. It's next to platinum next to platinum and silver, it's least reactive metals. It doesn't form a salt base or ionize. And something like sodium, which ionizes very easily and gives you salt, so sodium chloride, table salt. As human knowledge advanced, the mystical aspects of alchemy gave alchemy. As human knowledge advanced, the mystical aspects of alchemy gave way to the sciences we know today. And let's have a look at that, because, sorry for keep going off on this, because there's a lot of things here to unpack. Let's talk about Newton and the Philosopher's Stone. I'll just let Google do the autocorrection. So, but here's actual the manuscripts. Yeah, here we are. Isaac Newton spent most of his time actually looking for the Philosopher's Stone through alchemical experiments and all in his laboratory. Of course, the more enlightened scientists who took up Newton's work tried to sort of hide this hide this embarrassment, as it were, of theirs. But Newton himself actually went looking for it, and that's intriguing to me. It's intriguing to me because of the way I'm coming at my particular Big Bang Kilonova hypothesis, in using ancient symbology as artistic inspiration in the formulation of my ideas. The line of psychology I can find about this goes, I think, particularly Carl Jung, psychoanalysis Carl Jung, really kind of, I think, picked up on this. I particularly come across the work of Alan Watts, who's an English philosopher and speaker, and he particularly goes and he particularly catches on to this as well. And more recently, Jordan Peterson and the clinical psychological community seem to be picking up on this as well. It's like a lot of people are picking up on it, particularly physicists. And I've put my finger right on top of it. See, fractal geometry is the cosmological principle, and self-similar patterns repeat themselves irrespective of scale. Because of this, it is a mathematical certainty that this is built into us at the most deepest level. For example, CPT symmetry, charge parity time symmetry. It has a spiraling shaped sort of symmetry. I'll try and show you. It has this spiral shaped symmetry. And in fact, we can see that symmetry within neutron stars. So if I just bring up some of my new artwork, just happen to be that one. Ah yes, here we are. So it's got this, so here we are. So here's some of my new artwork showing this spiral paired symmetry that exists within nature. It exists within nature within RNA, a single helical strand. It exists within DNA, double helical strands. If I were, it's an image I need to prepare. There's one where you've got a picture of a cosmic web and a picture of the neurological structure of the brain. You can't tell the difference. The neurology of the brain looks exactly the same as the cosmic web. So fractal geometry is a cosmological principle, and self-similar patterns repeat themselves irrespective of scale, even if it be that in our artwork. But artwork, as I say, is subjective. But talking about the Philosopher's Stone is not. It's not because of. It's not, and we'll see why. So I'll just pause that and come back to. Yeah, there we are. Come back to the article. So yeah, they're explaining a bit of the background going into this. So, beginning again. For thousands of years, humans have reached for a way to turn matter into gold. Ancient alchemists considered this precious metal to be the highest form of matter. As human knowledge advanced, the mystical aspect of alchemy gave way to the sciences we know today. And yet, with our advances in science and technology, the original story of gold remained unknown until now. Now, it's particular that this is written in 2017 because that's when the first Kilonova explosion, and the light from that Kilonova explosion showed gold in its in the afterglow, which this particular article likes to show. Finally, scientists know how the universe makes gold. Using our most advanced telescopes and detectors, we've seen it created in the cosmic fire of the two colliding stars, first detected by LIGO via the gravitational waves they emit. I wonder why they're saying stars rather than neutron stars, because that's rather vague. But those telescopes are like Swift, Fermi. There's another one that I've been particularly reading about. They lock on and look for these transient moments, and there's a rather interesting article that goes really. This particular article I'll need to read right through. It's 89 pages, but we'll do that in another episode. But it particularly talks about the actual science of what telescopes are locking onto the areas where they think that a kilonova is going to happen because of the gravitational waves that precede it. So this talks quite a lot about the science of that. The electromagnetic radiation captured from GW170817, that's the first neutron star collision that was ever detected in 2017. So that's the name of it there. That's what it's called. And the 17 meaning 2017. So the electromagnetic radiation captured from the from GW1170817 now confirms that elements heavier than iron are synthesized in the aftermath of neutron star collisions. And it gives, that should give us a link to, hopefully, that should give us a link to the actual paper that talks about it. So this is the actual, we'll go over this one next, because that's the actual evidence. So, the origin of elements, baryogenesis is the full technical name, really starts with all the lighter elements, which are forged in stars. But when you get to iron consumes energy. The fusion of iron consumes energy, and this consumption rather than release of energy causes the star to collapse down in itself. And this particular graphic's rather interesting because it shows which ones are believed to where the elements are actually coming from. Are they coming from the Big Bang itself, where hydrogen and helium are formed? Most of these are actually formed in the fusion in the actual fusion inside stars. The lighter elements all the way up to silicon, but then when we get to iron, which is here, which is called iron peak, the fusion of iron consumes energy rather than releases it, and so the star, causing the star to collapse in on itself. When the star collapses in on itself, it fuses heavier and heavier elements together in a process called rapid neutron capture. And this rapid neutron capture process, as the star core collapses down on itself, is what was believed to cause the formation of all the elements heavier than iron, until the kilonova came along. And the kilonova, light from that showed, well, actually, rather gold is coming far more from a kilonova as opposed to the dying star. So here we go back. So the origin of our elements. Scientists have been able to piece together where many of the elements of the periodic table came from. The Big Bang created hydrogen, the lightest and most abundant element. As stars shine, they fuse hydrogen into heavier elements like carbon and oxygen, the elements of life. In their dying years, stars create the metals, aluminium and iron, and blast them out into space in different types of supernova explosions. For decades, scientists have theorized that these stellar explosions also explained the origin of the heaviest and most rare elements, like gold, as I was saying. But they were missing a piece of the story. It hinges on the object left behind by the death of a massive star, a neutron star. A neutron stars pack 1.5 times the mass of the sun into a ball of 10 miles across. A teaspoon of a material from their surface would weigh 10 million tons. I've got a little bone to pick there of that last sentence. Material from the top of the neutron star is more an electron degenerate form of matter, which is what white dwarfs are made of. But the material underneath is more compact and compressed until it becomes what's called nuclear pasta, or nuclear layers of neutrons upon neutrons upon neutrons, which are then got spaghetti in the As it comes down from the crust, you go from electron degenerate matter, and you get heavier and heavier uh, elements being, and more neutron-rich elements being created. Quite a lot of these elements, lower down the crust of the neutron star, could not exist if they were in the vacuum of space, because they're quickly they would have such a short radioactive half-life. Their nucleuses are unstable, but their stability is kept in check when they're inside the crust of the neutron star. Moving further down into the inside of the neutron star, you actually start to get into the actual neutron star itself within the mantle, where it is a crystallized structure of neutrons, or it's thought to be more a pasta-like layer, or pasta starting with spaghetti chains of neutrons, and then more a pasta-like layer further down into the core. Of course, the actual inner core itself, that's a whole different ball game. But for another time. I actually equate, but this last sentence, estimates vary, but I usually say one cubic centimeter of a neutron star weighs the same as Mount Everest. 5 billion tons. So it's not quite 10 million tons, it's 5 billion tons. A single sugar cube of neutron star matter. So if you actually had the component of the Philosopher's Stone dropped into your hand, it will go straight through your hand, straight through the earth, and down into the core. It will drive down into the core and become the new center of the earth, because it is the most densest form of matter. It's one step short of it actually collapsing into a black hole itself, and then that's where I have my particular description, and other people have theirs. Reading on. Many stars in the universe are in binary systems. Two stars bound by gravity and orbiting each other. Think Luke's home planet suns in Star Wars. A pair of massive stars might eventually end their lives as a pair of neutron stars. The neutron stars orbit each other for hundreds of millions of years, but Einstein says their dance cannot last forever. Eventually they must collide. So, not really Tatooine, I would say. It's more Eta Carina. Eta Carina being this lovely binary. There are two binary pair. There are a pair of binary super heavy stars in there, which when they go hypernova will give birth to either like a neutron star or a black hole. So probably most likely they'll give birth to a pair of neutron stars, and then in there, those two neutron stars will collide and create a Kilonova event. So this is Eta Carina here, and the two stars are hidden inside the mass. I don't know if it's if it's coming from a star that's already gone supernova in there. How's that look? Or if one of the stars is kind of like currently blowing off a lot of material at the moment. But in thinking about where in the superverse our universe is being born, it is being born, I think, inside a system like Eta Carina, or formerly like Eta Carina, which is surrounded by quite a lot of other matter. So that other matter interact with our universe, creating large voids like the Boite supervoid or the local supervoid around which our galaxy flows. So, if you want to know, in asking the question, where in the superverse is our universe to be found, I would say Eta Carina. Reading on. Massive collision detected, multiple ways. On the morning of August 17th, 2017, a ripple in space-time passed through our planet. It was detected by the LIGO and the Virgo gravitational wave detectors. This cosmic disturbance came from a pair of city-sized neutron stars colliding at 1/3 the speed of light. The energy of this collision surpassed any atom-smashing laboratory on Earth. So a large part of my film, The Anatomy of a Kilonova, is going to be describing this in exquisite detail. And so one of the new bits of artwork I did is showing a binary pair of neutron stars, or orbiting each other. So that's what we're talking about. Talking about two pairs of neutron stars that orbit each other before they eventually collide in and merge together. The gravitational waves from the two stars orbiting each other, it's detected by LIGO, and then that detection is passed on to the astronomical community, as it says come here in the next paragraph. Hearing about the collision, astronomers around the world, including us, meaning Harvard, jumped into action. Telescopes large and small scanned the patch of sky where the gravitational waves came from. 12 hours later, 3 telescopes caught sight of a brand new star called a kilonova in a galaxy called NGC 4993, about 130 million light years from Earth. Astronomers had captured the light from the cosmic fire of the colliding neutron stars. It was time to point the world's biggest and best telescopes towards the new star to see the visible and infrared light from the collision's aftermath. In Chile, the Gemini telescopes swerved its large 26-foot mirror to the kilonova. NASA steered the Hubble to the same location. And so here it is. Here is the actual event itself. So we're counting in. So the kilonova explosion happens, and 2 short gamma ray bursts are emitted. Short gamma ray bursts are about less than 2 seconds long. In a hypernova, they give off long gamma ray bursts, like the one that recently hit Earth was in October, was lasting for 10 seconds. So usually kilonovas give off short gamma ray burst, but the light from that, the electromagnetic radiation that is emitted by that, causes this patch of sky to suddenly become bright, and then as it cools down over the coming days, you see it dim. So it starts bright and then dims, and by day 10 it's almost dimmed down. It's almost gone. So I'm wondering if which telescope actually observed this one. So Harvard Smithsonian Center for Astrophysics. So dark energy camera, CTIO. I'm just trying to see which actual observatory actually recorded this particular observation, but it's on the. I think that dark energy camera, CTIO, is probably the instrument doing the measurement. Just like the embers of an intense campfire grow cold and dim, the afterglow of this cosmic fire quickly faded away. Within days, the visible light faded away, leaving behind a warm infrared glow, which eventually disappeared as well. So, it is this light that is then passed, this, which is then which is then passed through a prism, such that it splits up into a spectrum, and then the bands in that tell us what the elements within the elemental reactions that were present in the creation of that light, which is what we're going to here. Observing the universe forging gold. But in this fading light was encoded the answer to the age-old question of how gold is made. Shine sunlight through a prism and you will see our sun's spectrum. The colours of the rainbow spread from short wavelength blue light to long wavelength red light. This spectrum contains the fingerprints of the elements bound up and forged in the sun. Each element is marked by a unique fingerprint of lines in the spectrum reflecting the different atomic structure. So I just want to switch back here so we can, because I've got some nice so this particular graphic here shows the absorption line of hydrogen, where when light is emitted from hydrogen, it will have this very specific signature within it, these very specific bands, and so we can tell that light comes from hydrogen. And then, yeah, so that's what that is meaning. We split the light through a prism. We see see what bands there are within that spectrum, and that is the fingerprint of the elements that from which that light was emitted. The spectrum of the kilonova contains the fingerprints of the heaviest elements in the universe. Its light carried the telltale signature of the neutron star material decaying into platinum, gold, and other so-called R process elements. For the first time, humans had seen alchemy in action, the universe turning matter into gold, and not just a small amount. This one collision created at least 10 Earths worth of gold. So that's, I'm just trying to think of Fort Knox and how much gold that they used to have, I guess. I guess it's probably fairly empty nowadays. But, hey, that's a secret, eh? But 10 Earth-like objects made of pure gold from one kilonova. You might be wearing some gold or platinum jewelry right now. Take a look at it. That metal was created in the atomic fire of a neutron star collision in our own galaxy billions of years ago. A collision just like the one we've seen on October the 17th. And what of the gold produced in this collision? It will be blown out into the cosmos and mixed with dust and gas from its host galaxy. So this is actually where the gold comes from. Gold, platinum, silver. This is where it actually comes from. All the gold on Earth came from a kilonova. There's a particular paper I found which describes the very detailed. It's almost very detailed Sherlock Holmes forensic analysis that that Lee looks at very rare isotopes on Earth, and within asteroids and within rocks from other planets like Mars, the Moon, and asteroids from the solar system, but particularly from Earth. And we look, and it does a forensic analysis of actually saying, yes, these things had to come from a kilonova. So all that gold that you're aware that you might have, or might have in your bank account, or your vault really, that came from a kilonova. And so to call a kilonova the Philosopher's Stone is something that's very literal. And I just happen to become the progenitor of the Big Bang Kilonova hypothesis in explaining the birth of our universe, the birth of how our universe was born from a kilonova. The gravitational waves of that kilonova are seen in the large-scale anisotropies. Yeah. So yeah, I find myself in a rather interesting position of like, what have I just done? Well,